I'm going to talk about ink delivery systems, the components, and some of the finished systems. But just to start, for those of you that don't know us, or maybe know us specifically more as a supplier of electronics, drive electronics and software, our product matrix, our product portfolio has expanded considerably in the last few years. So yes, we're still a key player in all the electronics, but we've expanded our capability in software, application software for customers. We also now have a customizable user interface. And our whole remit is we work with OEMs and system builders and integrators, and often people that are completely new to inkjet but are using it and adapting it into lots of different application areas. So our strategy is to assist those companies and give them as many components and modules and assistance that they need so that their development time is as short as possible and so that they can get their product to market as quickly as possible. And so on the back of that, a few years ago, we were finding that because a lot of the printheads now have systems are getting larger, inkjet delivery systems are getting more complicated, and printheads have greater or more challenging requirements. We're finding that people were struggling also with building their own ink delivery systems. So that was why we decided to develop our own range. So we have the control logic, the software, the electronics, but also all the other components as well. And we now have hundreds of these systems in the field, and so that's the basis of me delivering this presentation today. But of course, we're not the only ones in the market. And here at this event, Industrial Inkjet provides ink delivery systems for the Konica Minolta printheads. SAR has the Hydra. Megnajet is also here and has a display area. And also we have a lot of the component suppliers like K&F is here and PAL as well, who were just giving a presentation in track 2. So I'll just cover some of the basic requirements of ink delivery systems, go through some of the flow modes, some of the key issues that are requirements of a system, and then go on to having a look at some of the issues and challenges that people have. So it's a very large subject, and so within the scope of this presentation, we're keeping it fairly high level. So in terms of basic requirements, we want to make sure that we're maintaining the head pressure at the nozzles within the required range set by the printhead manufacturer. It's one of the fundamental issues. And we need to maintain that meniscus pressure at the right flow rate, again, depending on the type of printhead. And on scanning XY systems, we need to be able to maintain that meniscus pressure when you're moving that carriage backwards and forwards. So it's got to withstand the acceleration and deceleration of that carriage. We also want to make sure that we don't get anything nasty getting into the printhead, so filtration is a key part of the system. We also want to stop things like air bubbles getting into the system and avoid air pockets within the IDS. And in order to do that, we may want to implement a degas system. Certain printheads actually require recirculation, and in some it's optional. And I'll go through that in a little bit more detail of where you might want to use recirculation. You often need to heat the printhead because the ink requires to be jetted at a certain jetting temperature and viscosity. And of course, you want to make sure you don't run out of ink. So you need a low-level indicator and the ability to pump ink up to the header tanks efficiently, and ideally be able to change those bulk tanks on the fly so you never have to stop printing, because we're talking about very large production devices now. And with those large production environments, you need to obviously have a completely, fully stable system. So explaining about flow modes, because we use some particular names or terminology, and just to make for clarity, I'll go through that. So a lot of heads are what we call our end shooters, and in those printheads there is no flow. The ink goes in and then goes out as required. We then have low flow, which sort of sits in the middle, where in the example here we've got a header tank that's got two levels, and you've got a height difference, and I'll explain a little bit more about this in the next few slides. And then in the third example, we've got adjustable or controllable flow, where we can actually specifically put a certain value and measure into how fast or how much volume of ink you're going to actually flow through the printhead. So those are the three terminals. We've got end shooters with no flow, low flow, and adjustable, controllable flow. So if we look at some of the basic characteristics of those three basic flow modes, And in these examples here, we've, just to keep conformity across the three, we've taken the example of a negative meniscus pressure of minus 50 millimeter at the nozzle plate. That's fairly typical. Some printhead manufacturers will have their own specification, but that's a fairly typical starting point. So in order to maintain that, we then also, the other typical range I should mention is that the air pressure range typically is between 250 and 500 millimeter, between the sort of midpoint of the level of the header tank and the nozzle plate. So therefore in this example, you need to apply a negative pressure of minus 350 and then to balance that with the positive head fluid of 300, that gives you your negative meniscus pressure of minus 50. So that's a basic end shooter no flow system. Similarly, if we move on to a low flow, which can be done with an end shooter printhead where you've got an inlet and an outlet. So here, again, we've just taken a height difference between the two header tanks. So this time you now apply the same negative air pressure across both tanks. And so they're constantly trying to level themselves out, and that creates this gentle low flow through the printhead. And this can be very desirable with certain inks, and I'll cover that in a bit more detail later on. And then finally, as mentioned, we have this controlled or adjustable flow mode. And here you have two pressure values assigned. And it's the printhead manufacturer that will tend to specify that pressure difference. It's often very specific to the printhead. And then you have a differential air pressure creates that flow through the printhead. The advantage of this system is you can also specify and vary the flow rate depending on the different types of inks that you might be putting through that printhead as well. And to give some examples of how these might be implemented across different printheads. So for the controlled flow, the adjustable flow, that is absolutely required for printheads, for example, from Fuji in their Samba and the Starfire, from ZAR, and we had the presentation from Angus yesterday, explaining much more about that in detail, and also T-Tech. So all those absolutely require a controlled flow system. And then at the other end, we've got the end shooter, the no-flow printheads, such as some of the older technology printheads from Fuji, the Sapphire and S-Class, for example, and Nova Galaxy. We've got the Konica Minolta printheads, the Kia Ceras, and Ricoh. But what we've found with some of the systems that we've been building is that for certain reasons, with certain fluids, it can be beneficial to actually create a low flow through those printheads. So that's why in this chart, we put those down as optional. It's not required, it's an option that you can implement if it makes sense to do so. And then some basic ink requirements that you have to take into account. So if you're working with a UV ink, typically requires heating. The head might have a heater. You might want to use a heated head mount or implement inline heating, and I'll go through heating in a little more detail. You may also actually want to degas a UV ink, and as the systems are getting larger, we're finding that that is also becoming a more prevalent theme. An aqueous ink typically needs degassing, but not always. Mostly on a no-flow printhead, an end shooter, or often not, degassing isn't used. It's much more beneficial in a low flow or an adjustable flow printhead. Oil and solvent typically don't need anything special. And then when it comes to some of the more special fluids that are being used, for example, like a white, which is more heavily pigmented, or a ceramic ink, then those may require a special pump, not only because you need a stronger pump to get that around the system, but you also need to select a pump that can withstand the abrasion that may be happening within that ink when it's running through that pump. And then finally, for those going into functional fluids or specific fluid deposition or in ink development, then here, obviously, if you're working with a very novel fluid, you need to do extensive materials compatibility testing with all the parts throughout the system. And you also need to take into effect that a lot of those fluids may be very high value, and therefore you need to adjust the size of your header tank so that you're not using up a huge amount just to fill the printhead. So moving on to some of those specific aspects. And in terms of heating, as I mentioned, certain inks, the performance of inks certainly varies with temperature. Some require them to be heated so that you reduce the viscosity, so that you get the correct viscosity at jetting and at the correct jetting temperature. And most inks will have a recommended operating temperature, which your ink provider will be, give you those details. And of course, most critical is maintaining that temperature requirement when you're actually jetting at the nozzle. And there are various ways that you can implement heating in an ink delivery system. You can have an inline heater, and those are typically work with recirculating systems. They can add cost, certainly, but they are the most efficient, fast, and controllable way of setting an ink temperature and maintaining it. On a no-flow or a low-flow system, you could actually heat the header tank itself by putting a pad or a jacket on it. This is much lower cost, less efficient, but again, for a lot of systems, it works absolutely, it works fine, and typically suitable for low-density printing. And then also you can heat the head plate itself, and that could be used across all flow modes. And it's something that we would typically recommend, regardless of the ink type, because if you're controlling that temperature area at the print heads on the head plate, then you're guaranteeing that you've got a uniform thermal environment, regardless of what's happening outside in the ambient environment. And also the heated head plate also reduces the workload on the other parts of the system, whether you've got a heater in the print head or on the ink system itself. And as I mentioned, degassing is another important feature of IDSs. It's typically required for aqueous inks, but not always. And so on some small systems or with end shooter systems, you don't always include it, because it's much more effective if it's in a low flow or a controlled flow environment. And also, as I mentioned, it's beginning to be recommended for some UV systems, and typically those where you're getting a very much larger number of print heads, large amount of fluid, and where you're printing at very high frequency. But if you are applying degassing to UV, then you must make sure that the vacuum in the system is also very carefully controlled. You have a lower vacuum for a UV ink than you do for an aqueous ink, because if you apply the vacuum too high, you're going to strip the oxygen out of the ink and everything's going to cure. So everything is a balance. And then, of course, you must also select the right contactor at the right size for the flow rate that you're using, and also make sure that that also is compatible with the ink and isn't going to suffer from any abrasion as the ink is passing through it. And certainly at Drupa, we saw a huge development in terms of very large print bars, and this is becoming the norm now, sort of 1.8 meters wide, 2 meters wide. This is becoming standard, and this again creates huge challenges for an ink delivery system and how you design it. So I thought I'd go through a couple of the basic designs that are being used. You can either have a header tank and then a manifold system underneath it. This is a very popular way of designing an ink system. It's very cost efficient to implement. Can be prone to air traps, arguably, as an air bubble can get trapped here at the top end of the manifold rather than getting up and then being recirculated as required. But the other advantage of the manifold system is that it's also extendable for wider arrays. The other option, and this is what GIS does, is you can actually have a customized header tank. And then the header tank actually acts as the manifold, and you've got a valve for each print head. You've got equal flow resistance, and this again is extendable, but not infinitely. So in this example, at the top, we've got a header tank for 4 print heads, and then underneath is one for 12. So you can see the concept of it being extended. But you wouldn't necessarily take that, you wouldn't extend that to 24 heads. You'd use 2 12-head modules, for example. And then, so what are the common issues attributed to an ink delivery system? Well, they are numerous. If you don't get drop ejections, then you might get misdirected jets. That could be blamed on the ink system. Any sort of lack of uniformity in print density as you're printing, that can also be contributed to a factor that's failing in the ink delivery system. And of course, if you've got blocked nozzles, if you're allowing air to get sucked into the print head, if you've got ink weeping out onto the nozzle plate, if you've got blocked nozzles, then because of some materials incompatibility in the system, all those can potentially be caused by an ink delivery system that's failing. But we need to put that in context, because in every inkjet system, it's all an interlocking puzzle. Everything depends on all the other systems. Everything is have to have that synergy. So actually, what you might think is an ink delivery system could actually be the fault of another part of the system. So you'll be able to look at this in more detail when you get the PDF and blow this up. But this was just a quick mind map that we did in the office, thinking, well, if you've got this problem, what could it be caused by? And you start drawing all these lines, and you begin to realize what I mean about this completely interlocking system of a total machine. You can't always blame one particular issue on having one specific cause. Everything needs to be troubleshooted in a very systematic way. So I can't cover all of the different problems that you might encounter with an ink delivery system. So we've just chosen a few of the key ones. And starting with trapped air. And the symptom of that, you might find that it's very difficult to start the printhead in the morning. You're not getting a clean print, first of all. You might get ink dripping from the nozzle plate, even when the pressure says that it's set correctly for the meniscus. You might find the very irritating process of you might get intermittent printing, where it may print well for a short time, but then when the air bubble travels into the head, then things start to go wrong. Or it may print well at low density and then fail very quickly when you're printing something with very high amount of coverage. Solution is to potentially degas the ink. Also, in terms of the design, you want to try and make sure that you don't create any air traps in the system. So you want to avoid your tubing that has any uphill path or any looping. You also want to make sure that the tubing that you use for the ink is the right size. You don't want it too small to cause restriction. You don't want it too large either. If it is too narrow, then that potentially means that you could end up with air being sucked into the nozzle as the head fails to pull the ink through the system at the required rate. And the other thing also in the system is you need to avoid any other restrictions that might occur from things like the valves and the fittings that you're using. Another key issue is poor pressure control in the system. Again, the symptoms can be the ink dripping from the head, or again sucking air into the print head. Again, you can get the same sort of variations in optical density as the volume of ink can be affected. It's not uniform. Again, the causes could be that the vacuum pump on has been left on continuously, so creating a loss of pressure. You might have dirt in the vacuum pump diaphragm. The vacuum setting might be incorrect in itself, and also you might get pulses, so you haven't got this smooth pressure going through the system, which is what you really want. So obviously, solutions for that is to maintain good control over your vacuum pressure, and you want that smooth flow control. You don't want the system to be pulsing. And of course, you also want to make sure that you don't run out of ink. So you want to make sure that you're maintaining an adequate flow of ink. Sedimentation is another potential problem when you can get your heads will begin to clog. Or parts of the system might clog, so your filter gets clogged, and that reduces the flow rate to the heads. And the potential causes of that are heavily pigmented inks. I mean, white is being used much more in printing systems now. Or, unfortunately, you might have an unstable dispersion if you're developing a new type of fluid and learning more about its characteristics. So some of the straightforward solutions for potentials of sedimentation is to recirculate, either in low flow or in adjustable flow rate. And so that's where one of the examples where you might be using an end-shooter printhead, maybe for CMYK, and then you could do that with no flow. But if you're adding a fifth ink station with white, then that might be an example where you'd actually, on that part of it, implement a low flow. And that way, you're not going to run into the same problems. You also potentially need to use special pumps. And again, I've covered that before. They need to be resistant to abrasion and wear. And the other thing that you can also do with a heavily pigmented ink is you can actually have some additional agitation down at the bulk ink supply. So lots of different options to work around. Materials compatibility, again, much more critical when you're dealing with functional fluids and developing something brand new. But even if you're taking a proven ink from an existing supplier, you also then actually have to make sure that you're using materials, particularly in your tubing, that don't cause horrible particles to start leaching into the ink and therefore traveling down towards the print head. And a very typical one in terms of tubing is that some people who are new to inkjet or not as familiar will start and build a system using silicon. And of course, it's just a complete nightmare. So typically, you should use an FEP or PTFE and talk to your ink manufacturer and supplier to make sure that you're using the right product. Otherwise, you're going to end up potentially with a lot of very expensive problems to fix. And then, of course, you can just have general system unreliability, where it's very difficult to diagnose the specific reason for it. And that's really where you have to go right back to basics and check everything that you have built within that system, looking at, diagnosing, have you got the right type of pumps? Have you got the right type of vacuum? Are you using, have you tried to save money and use poor quality and cheaper components? Do you have the right control logic and software actually managing the whole system? So it seems fairly straightforward, but it's often a very good way to troubleshoot and examine exactly what components have been used in the system. So in summary, it really all comes down to good design and planning right from the start. If you do that and do your homework and build everything with the good quality components, and follow the guidelines from the ink suppliers and the printhead manufacturers, that's going to put you in a good starting point. And typically, if you're working on a machine for the first time, we would almost recommend over-specifying the prototype. You can always cut back and reduce costs later. It's much easier to do it that way than build a local system and then try and improve it later on. And as I mentioned, the low flow use with end-shooter printheads is certainly growing from our experience and companies that we're working with. And as I gave that example of, having no flow for the CMYK and then a low flow for a white. And then generally there is this trend in the market. We've got a lot of the printhead manufacturers here today showing their latest printheads. And more of them now are using this recirculating with a controlled flow. And this does make it much more demanding for ink delivery system design and implementation. But I hope I've given you a few pointers to start you off on that road. Thank you.